So this is your question number 3. Why are pole pieces of galvanometer made concave? Okay. So galvanometer, if you see, now you need you know this the galvanometer, how it works. It works the principle that whenever a current carrying loop is placed in a magnetic field, it experiences a torque. Okay. The torque is given by, suppose this is your current carrying loop, okay, like this, and magnetic field is going in this manner, okay, and suppose this is the loop, this is the surface, isn't it? This loop I have kept like this, in this manner. So this is normal, okay, this is called the surface vector. Normal to this loop, actually normal will be how? It will be something like that, right? Yeah, this is the normal, okay, this is the surface vector. So let me denote it by n cap, okay, surface vector. And suppose this is your B, this is your B, like this. Let me draw it properly. This is your surface vector, okay. So loop is something like this. So there is the perpendicular, okay, on this surface. And suppose B is this is your B, then this angle, if we consider it as theta, this is n cap, this is perpendicular to this surface, okay. So this is the called surface vector, okay, surface vector, and B angle is theta. In that case, the force on this loop, suppose this is A and this is B, the torque on this loop will be T external. Why we say T external? I am telling because the current is flowing, no. Whenever current is there, then only this torque is acting, right? So T external. So T external is equal to I B AB sin theta, okay. This for one loop. So for this, for one loop, for one turn, or one loop, for one turn. If there are n turns, then in that case what will happen? T external will be N I B AB sin theta, right? And AB is nothing but that is the area of this plane of the loop, right? So I can say N I B A sin theta. Can I say that? So this is where AB is the area, okay, AB is the area. So T external. Now what happens? This is one marks question only, okay, but anyway let me explain you. This galvanometer, then only you can feel the answer how it is coming. This galvanometer is connected here by a light wire, okay, very light, and it is bottom you have the spring, okay, and here you have the scale, like this, okay, fine, this is the scale. So whenever current flows through this, there will be the deflection. That deflection, let it be theta, phi, I will take it as, because theta I have taken here. So that deflection is phi, okay. Suppose at when there is no current, that time this is at this position. When current flows, then this is moving like this, phi angle, right? So more the current, more should be the deflection, right? So that means I should be proportional to phi, right? More the I, more the phi should be, isn't it? So when it due to the torque it will be twisting, right? When it twists, the spring is also getting twisted in opposite direction. Okay, so their energy will be stored in it. Due to that energy, it will develop a restoring torque. Okay, it will try to bring it to the zero position. So that restoring torque is equal to spring constant times the deflection. Okay, spring constant times the deflection. So at equilibrium, what will happen? T external will become tau external will become tau restoring force, right? So this is nothing but N I B A sin theta is equal to C phi. So I is equal to what? C, all the constant I will write here, N B A phi by sin theta or not, right? This will be phi by sin theta. Now there is the problem, this is the constant. Okay, so I can say I is equal to K times phi by sin theta. Okay, hope it is there in the board. Yes, it is coming. Yes. Fine. So this is the problem. I should be proportional to phi alone, but it is phi by sin theta, right? So in order to get rid of this sin theta, we take this cylindrical. Cylindrical means concave type magnetic pole, right? It is like this. Let me draw here. It is like this. So if I take the concave, what happens? The field will become, the field will be radial. Okay, so this is, suppose this is your north pole, and this is your south pole. So these are the fields, right? Field will be radial, like this. So whenever the field is radial, then in that case what will happen? That surface vector, the surface vector will be perpendicular to this. In that case what will happen? So the concave shaped magnet makes the B radial, right? That is the reason we. So if it is radial, then what will happen? Therefore theta is equal to 90 degree, right? So now what you are getting, I is equal to K times phi by sin 90, right? Sin 90. So I is equal to K phi, isn't it? So I is proportional to phi. Now we have got the sin theta, we could eliminate it, right? So due to this radial field. So this is the reason. It makes the B radial. Okay, and consequently this theta become 90 degree, and that's the reason we get I is proportional to phi. That is what we expected, right? Thank you. So this is the answer. Hope you have understood it. Any doubt, write in the comment. Okay.